welcome to CEC lectures. Myself Dr. Preeti Jagmani. I am an associate professor, Department of Computer Science, Aryabhat College, University of Delhi. As you all are aware that presently we are learning our series which is titled as Programming in Java, and in this particular series since last couple of lectures we have started a new topic which is multi-threading. And in the last lectures we have seen that what actually multi-threading is and what is the need behind this concept. So multi-threading, when we talk about, is actually a kind of we can say way to do multiple task or multiple way to execute multiple processes simultaneously. That can be done with the help of programming languages at micro level, if I am talking about, or that can be done with the help of operating system as well. So here we are talking about the kind of multi-processing or multitasking, I can say, which can be done with the help of the concepts of threads. And now taking forward in this lecture, if we what are we going to do? We will be looking into first two small but very important concepts. One is synchronization and another one is messaging, and these two topics will be later on used in our programs. And then after we will be looking into how to create threads, because till this point we have not gone through any practical example or any program of thread. So in this lecture we are going to do that. So coming to when we talk about synchronization, so multi-threading is something that is as I have told you just now, that this is execution of multiple processes simultaneously. So what will happen here? So this multi-threading essentially will introduces an asynchronous behavior to the programs, to our programs. So asynchronous behaviors to this program or to our programs, then we need some way to enforce synchronicity. Now let us try to understand when I am saying an asynchronous behavior, what is that asynchronous behavior? So asynchronous behavior says, let us say two threads are going on are being executed simultaneously, and they are sharing a data structure. What kind of data structure I am talking about? Let us say linked list. Let us take the example of a linked list here. So two threads going on simultaneously, being executed simultaneously, and they are sharing a data structure which is linked list. Now what will happen? We must have one way to prevent one thread from writing the data onto that data structure while another thread is in the middle of reading it, and that's a very common requirement which should be there in order to avoid any kind of inconsistency into the outputs or into the data. So we need to prevent one thread from writing the data while another thread is in the middle of kind of reading it or in the middle of writing it. So that means these two threads will be requiring to communicate, that is the first thing, and then there should be some way that through which we can ensure that these two threads are not going to conflict each other. So first is they should communicate with each other, and we also need to ensure that even after communication they should not conflict with each other. So here is what the concept of synchronization comes into the picture. So now synchronization, when I am talking about, so going through with the our previous series of operating system, if you remember, can you recall any of the concepts which is there to introduce, or which is there to ensure the property of synchronization within two processes going on or being executed simultaneously? Are you able to recall any such technique, any such synchronization tool? If yes, that is good. So here which tool I am talking about is various synchronization techniques we have gone through in our series of operating system concepts. For example, semaphores, and then we have monitors. So here is something which I am talking about, the term or the synchronization tool which I am going to use here is the monitor. Now let me help you recalling that what actually a monitor is. So monitor, you can think of it as a small box inside which one process is going on, and that particular box can hold only one process. So, here in terms of multi-threading, or here in terms of threading, when we talk about, we can take monitor, or we can think monitor as a very small box that is going to hold only one thread at a time, because here the processes which I am talking about are are actually threads. So, once a thread enters a monitor, all other threads must wait until that thread which have entered exit the monitor. So, once a thread is going to get into the monitor, others who are waiting for waiting for that monitor to be accessed must wait, because as I have told you that monitor, that small box can hold only one thread, and this wait will go on till the thread exits the monitor. And in this way, monitor as a synchronization tool can be used to protect a shared asset. So, from being manipulated by more than one processes, by more than one threads at a time. So, basically my monitor is actually a tool, or we can say it is a synchronization technique through which we will be able to protect a shared access from what? From being manipulated by more than one threads at a time. Now, if I am saying can be used to protect a shared asset, which shared asset I am talking about here? In this particular example, I have told you that these two threads are working on the similar data structure, which is the linked list. So, here it is the linked list, or the data of the linked list, which should be prevent by being manipulated by two threads, or more than one threads simultaneously. Why? Because this is going to ensure inconsistency if we allow two or more than two threads if we allow two or more than two threads to access the that shared asset simultaneously. So, one should complete it, and unless unless that first thread has not kind of released or relinquishes the monitor, others must wait in in a corner, or we can say in a queue or whatever. Now, the question comes up, how are we going to ensure this synchronization technique to be implemented, or how are we going to implement this concept monitor? So, first of all, let me tell you, in Java we do not have any class such as or which is going to help us in implementing monitor. So, there is no such class named as monitor with that functionality. Now, how are we going to do it? So, here we have each object has its own implicit monitor, and that object will be automatically considered as entered into that monitor when one of the objects synchronized method is called. So, basically let me reiterate here, we do not have any concept which is known as, or we do not have any class which is known as monitor. So, in order to ensure this synchronize, or in order to implement this synchronization facility, each object we have we are going to create has its own implicit monitor, and object is supposed, or object is considered as automatically entering into the monitor when one of the objects synchronized method is called. So, if we want to kind of if we want to implement the object, if we want to implement the entrance of the object inside that small box, inside that monitor, for that we need to call the synchronized objects synchronized method. And once a thread is inside that synchronized method, that means no other thread can call any other synchronized method on the same object. So, that means on one particular object only one thread is allowed to call a synchronized method, and if one particular synchronized method on a particular object is going on through a particular thread, no other thread will be allowed to call any other synchronized method on the same object. So, in this way we will be able to protect that linked list which we were talking about by being accessed simultaneously by more than one thread. Now, what is going to be the advantage for this? This is actually going to enable us or enable a programmer to write very clear and kind of we can say very clean multi-threaded code. And the best part here is this synchronization support is built into the language itself, is built into Java itself. So, it is not built in the form of a class titled as monitor or as a it is not built in the form of the class monitor, but yes, we have synchronized methods through which we will be able to implement this concept of synchronization or this concept of monitor. So, we can say that synchronization support is built into the language itself. So, now summing up this process of or this idea of synchronization, we have two threads working on the same object, and in order to make secure a particular asset which should not be simultaneously accessed by two or more threads, we need to have a synchronization technique, we need to have a synchronization tool, and the support for synchronization is built into the language itself with the help of synchronized method. So, this is what we can say is the concept of synchronization. Now, in the starting of the lecture, I have told you that we will be covering or we will be looking into the concept of two ideas or two fundamentals. One was which is synchronization and another one is messaging. Now, messaging, as the name indicates, it's a simple idea in the sense, let us say we have two or more than two threads going on simultaneously, because I am talking about threading, that means they are working simultaneously. We have some threads which are actually separate, and there is a need that these threads are required to be required to communicate with each other. Now, the question comes up how they will communicate with each other. In some of the programming languages, there is no built-in again support for messaging, and for messaging those languages some languages which are not having inbuilt support for messaging. So, when programming with these type of languages, these languages must depend on the operating system to establish the communication between threads. Now, immediately the query comes up, what about Java? So, thankfully, by contrast, Java provides a clean, also a low cost way for two or more threads to talk to each other. Now, why I am saying low cost way? Because when we are going to kind of provide this support of messaging within the programming language itself, this is going to cause overhead, that is significantly kind of we can say considerable overhead activity. But unlike this concept, Java provides a clean as well as a low cost way of ensuring or of establishing the communication between two or more threads. Now, what is that way? I am talking about a clean, low cost way. So, the way is this is implemented via calls to predefined methods that all the objects have. So, all the objects have some predefined methods, and by calling those predefined methods we can establish messaging, we can say messaging or communication between the thread. And this Java's messaging system allows a thread to enter a synchronized method on an object and then wait until some other thread explicitly notifies it to come out. So, what does that mean? This situation means that once once a thread enters into a synchronized method on an object, it can send some message or a message is being sent to all other threads, and those all other threads must wait until it has been notified that the thread which has entered is now coming out, or now has kind of come out. So, Java's messaging system allows us or allows a thread to enter a synchronized method on an object and then wait there until some other thread explicitly notifies it to come out. That is also a possibility. So, here we have seen two concepts. One is the concept of synchronization, what is this, why it is required, and interlinked with synchronization we have our messaging idea. And please hold on with the theoretical concepts of these two points or these two ideas, as we are going to use them soon within our programming approach. Within this couple of lectures, we have not created any of the thread, or we can say we have not come up with a program which is using this concept of threading. Now, in order to create a thread, we have two ways in Java. One way is to extend the class thread, and another way is to implement runnable interfaces. Now, what is this extending the classes, and what is this implementing the interfaces, that we have already seen in our previous lectures. So, extending the class, I can say there is a parent class and a child class who wants the functionalities which are there in the parent class to be inherited. So, this child class or the subclass will be inheriting the parent class, and the term used for that is the extend, or we can say the child class is going to extend the parent class. So, that is what the concept of extension or hierarchy in the classes is. Or we can say inheritance in the classes. Another way, that is to implement an interface which is named as runnable. So, this runnable interface will be classes are extended and interfaces are implemented, and when we are implementing the interfaces, we need to make sure that the functions which are given as given their signature inside those interfaces should be given the body or should be implemented by the class which is kind of calling that interface or implementing that interface. So, two ways, one is through inheritance, which is extension of a class, and another one is through interface mechanism, that is implementing a runnable interface. And this Java's whole multi-threading system is actually built upon the thread class, and this thread class is having various methods for different types of tasks, and also not also this thread class, but the its companion interface which is runnable is also holding the fundamentals of this Java's multi-threading system. Now, the question comes up that why Java has been given, or why it has been given in the programming language the two different ways of doing the same thing, because in order to create a thread, we can extend the thread class, or we can implement the runnable interface. Now, why two ways for doing the same thing? I will be covering this in in our upcoming slides, because these two methods are having their own pros and cons, they have their own significances. Now, in order to create a new thread, as I have told you, the program will either extend the class thread or implement the runnable interface, and the thread class will have several methods that help managing those threads which are being just created. Now, when we say threads, so the question here is, have we used threads till this point in this course, or whatever programming we have learned till this point, have we used threads? So, yes, we can say yes, we have we have used threads, but we have not used multi-threading, because till now all the example in this course which we have kind of implemented have used a single thread of execution. And which is that single thread of execution? that single thread of execution is nothing but main thread. So, that means we have used the concept of threading, although with the help of a single thread, but we have not used the concept of multi-threading, but threading, yes, we have used in our programs. Now, here onwards we will be having multiple threads in our program. So, initially in the starting of some programs we will be having only two threads, one is the main thread and another one which we are going to create, and then maybe in the some upcoming programs in the future slides we will be having more than more than two threads apart from this main thread. So, first of all, let us try to study this main thread, because we are kind of very familiar with this, as we have all the programs written using this main thread. So, main thread, if we can say, all you are aware that you all are aware that this main is till this point we what we understood using this what we understood by this main is that this main is actually a method from which the execution of the program starts. So, that is a perfectly kind of we can say acknowledged or perfectly fine concept. When we talk about this main as in thread, so we can say that when a Java program starts, one thread will begin running automatically or running immediately, and this is usually called the main thread of the program. Now, why this is called as main thread of the program? Because it is the one that is executed when the program begins. Now, as far as threading is concerned, is it important to have a main thread, or what is the importance of this main thread? So, if we want to perform the concept of multi-threading, or if we want to implement multi-threading, so main thread is something, or main thread is the thread from which other threads will be created, or the technical term for that is from which other child threads will be spawned. So, it is the thread from which other child threads will be created, will be spawned, and it is often in most of the cases it is the last thread to finish execution, because it is going to perform various shutdown action. All other threads which are being created with the help of this main thread as the child threads of this main thread will finish their execution before the main thread, and this main thread will often be the last thread to finish the execution, but is because various shutdown actions this has to be performed. Now, as I have told you that this main thread is created immediately and automatically when a Java program begins running. So, can we control this thread object, or can we control this thread? This thread is created automatically when the program is started. Can it be controlled? Yes, we can say that it can be controlled through a thread object. So, in order to control that thread, which is the main thread, we need to obtain a reference to that thread through some particular method, and then with that reference we will be kind of we can say looking into what all can be controlled, or how execution of this thread can be tweaked or can be controlled. That we will see or I mean a complete full-fledged program, that how this main thread can be controlled, that we will be able to see in our upcoming lectures. So, in this lecture we have seen the concept of synchronization, the concept of messaging, and then after that we have seen that there are two different ways of creating the threads, and then we started looking or drilling down into the concepts of the main thread, which we which we have always implemented through our programs. But now we will be looking that main with the glass of our threading concept, or with the eyes of our threading concept, and the full-fledged upcoming full-fledged programs regarding that will be covered in our upcoming lectures. Here is a list of references which is being used for the preparation of lecture. As you can see, it is available on the screen, references. I hope you have enjoyed the lecture. I will see you in the next one. Till then, take care. Goodbye.